We're given that 5 to the p is equal to 9, and then we're told that 9 to the q is equal to the 12. So if I take 5 to the p and raise it to the power of q, then I will get 9 to the q and it'll equal 12. And that means that 5 to the pq is equal to 12, and we've set up a route to get to the answer, okay, because what I want to get is 5 to the pqrst. I just want to say I've used the idea that x squared to the power of 3 is equal to x to the 6. You simply times the indices together, because this is x squared times x squared times x squared. I'm timesing 6 lots of x together. In general, it becomes x to the a b is x to the ab. So this is going to be used constantly throughout. And I just keep doing the same thing now. So 12 to the r is 16. So 5 to the pq all to the r, which is 5 to the pqr, is going to equal 16. Then I'm going to raise 16 to the power of s. So I raise this to the power of s as well, which becomes 5 to the pqrs. That's going to equal 20. And finally raise all of this to the power of t, which becomes 25, or 5 to the pqrst is 25. Let me just clarify, explain this one in a little bit more detail. I tried to, hopefully I did it earlier on enough. So I'm basically saying, right, because this is true, I can just raise the left-hand side to the power of t and the right-hand side to the power of t. But this is equal to 25. We're told that right here. And this on the left-hand side just becomes 5 to the pqrst. So that's how I got to here. Now 25 is actually 5 squared. So I write it like that to make the powers the same. Sorry, not the powers the same, the base is the same, and therefore the powers must be equal. It must be that PQRST is equal to 2.